While I was tinkering with my 5010 motor, I found a screw on the back. So I looked it up. There's two versions. There's a new version and an old version. The one I have is apparently the new version, which has a screw. The old version has a shaft with one of those little things that you have to remove to get the shaft out. So that's what I tried with the new version. I tried getting the shaft out so I can modify the shaft and put a D shaft in, but it doesn't come out at all. I don't know why. I think they used Loctite because the screw had Loctite in it. So I have basically no way of getting it out right now. So what I did is I put a bolt in and I put a nut inside the bolt. So it's a hex nut on the bolt. So that way I can use the hex nut to attach to the 3D printed part to make it spin. So yeah, so I'm gonna create a new one. This is gonna greatly reduce the profile. And this is gonna look amazing. It's gonna look so good, and the performance is gonna be great. It's gonna be even better and lower profile. And I also opted out of using M3 nuts, M3 bolts, I mean screws, for just 3mm rods. 3mm rods are typically 2.9 something, and it's good because I can slide a ball bearing on. That's the exact size that I have right now, which is a 3x8, I think. So reduction ratio, I'm going 25. Eccentric amount 1. Ring pin diameter. Wait, eccentric amount. Can I go higher on eccentric amount? I do believe the higher the eccentric amount, the more load torque bearing it can be. Would 1.1 1.1 would work. So let's check. Yeah, let's go with a 1.1. And also the ring pin diameter. Should this be a big or a small number? I don't really know. Let's try doing 5. With that, I don't know. Let's stick with 4. And okay, so with this new design, we can make the overall profile a lot smaller. So instead of 65, maybe we can do just 60. And then just do 1. This will be easier to remember. 25, 1, okay. And then draw center hole. This will be 21 because of our 15, 21, 4. Draw hole around center, draw output disk, we'll do output pin disk. This will be 8. Pin number. 6 is more than enough. Pin diameter. Pin diameter. Let's go with 8 because we're using 3x8x4. Ball bearings, distance to center. Let's look at this. Let's see. Okay. This is very nice looking. One thing we have to take into account is the outer ball bearing that we will be using. And okay, let's see here. Because the outer ball bearing will be 50 by like, I don't even know, what is it? So 50 ball bearing, 50 by 65 by, well, I think there's actually a 50 by, I think there's a by 6, is there not? I want the by 6, there we go. Wait, no, not this one. 50 by, it's all by 7. Oh, there we go. Wait, by 62. This is 65, so we definitely need this. Dude, I thought I added this to cart. It's not. Okay, add to cart. Okay, let's take a look at this. So this is the 50 by 62 by... Okay, so from here to here is 30, and then the diameter is 10, so it would be 50 out here. We could potentially make this go in a little bit to add a little bit more strength. Instead of 40, we can do... Instead of 42, we can do 40. This seems pretty promising. Let's go a little bit lower. 38. Okay, let's just create this. Okay, nice. So we'll do, what was I thinking? I think we'll do 5 here, and we're gonna try a triple gear system. Okay, so, and we're gonna add way more, what's it called? Way more clearance to everything. Yes. So this is 5, and what we're gonna do here is go to bodies, M. So we're gonna have another 5, a 5, and then another 5. So we're gonna have 1. So it's gonna be up to, wait, no. We need to copy paste. So this is 5, so we need to do 17 right there. And let's get rid of this for now. And we need to do another copy of this, copy paste. Bring this up 6. Go to the top. And click OK for now. What we can do here is go here, create sketch, -1. New body, click OK. And then here we can do a, this is body 3. Yes, this is body 3. And do it, move, set the pivot about the center. Press OK. We need to move it this way by eccentricity sum 2, which is just -2 because it's -1 times 2 is just -2, and rotate it about the center by 180 divided by 25. And now we can see that this lines up, but the center does not line up. We can click OK here. Let's go here, create a sketch. And we can do a -5. Now that we have this, we can do, go back to sketches, bring up sketch 2. Here we can do a -5. We can do a new body, and then we can rotate this about the origin too. Move set to the origin, which is right here. Now we need to do a -180 divided by 25 to bring it back to where it was. There we go, perfect. Now we can join. This, join. Nice. Now let's turn off sketches for now. This piece right here, what I want to do is extrude this out by 10. I mean by 5. This is a triple gear. A triple disc. And let's bring back this body. And now look at this. This is perfect. 1 millimeter space between. And this should not have any, what's it called, vibrations, because the mass of this and this is equal to the mass of this. The top one plus the bottom one is equal to the mass of this. And they're out of phase by 180 degrees, so this should be perfect. And a lot more load bearing, torque bearing. And one thing we're going to do this time that is going to be dramatically different is all of these will be just 3D printed. Doing the dowel rods is a pain. You get into tolerances, right, and then it not fitting and blah blah blah. It's just a pain. So we're gonna try this time and see how it works. And it will reduce the weight by a lot. Okay, so I had a 20 plus 2, 22, so we can extrude this by 22 for now. And now let's connect everything. Should we do that or no? Let me think. Okay, let's close the sketches here and just do extrude. Okay, so it's extruding down for some reason. I don't know why. Let's do a... Oh yeah, this is great because we're not using dowel rods. We don't need that much clearance. Let's do 2. Join, and from here to here is 24, so we need to do a 26 if it goes the wrong way. Yep, it went the wrong way. So -26. And do a join. Okay, nice. Now let's bring in all our bodies. Okay, this is looking pretty cool. Now let's get rid of this for now. This piece can get deleted. No, what did I just do? And let's go, let's see here. Let's create a sketch and combine every part. Just go somewhere around here. And the outside, let's go 70 for now. We can always change this later. -65 join. Would it be beneficial to create fields here? I don't know, don't care. Anyways. So now that we have this set up here, let's actually go over here. Wait, not over here. We need to insert let's insert the motor. How do I do that? Where is it? Oh, there it is. Save and continue. Let's name this new drive V version 6 cycldoaidal. Okay. Now that we've done this, we can go here, click select. Select this entire thing, click OK. Nice, click and move. Okay, okay, this is the top, this is the bottom. I'm trying to think, should we place this on the top or the bottom? Let's place it on the top, so if we need to ever go render it, it would look nice. Okay, and we don't need this part. And let's make this go away for now. Okay. Now that we have this, what's the bearing? It's 50 by 62 by 6. Okay. Let's make a bearing too. So 50 by 56. 6. Okay, nice. We have a bearing now. Appearance. Is there glass? Okay, let's just do this color for now. Okay, so I've never made it like this before. This is a more compact way of doing it. And so these, I opted out to use 30, I think. Why? Okay, appearance is still here. How do we close out this, bruh? Close. Okay, there we go. 30. Wait, let me think here. Okay, so we have from here to here should be 22. That's correct. So we need another 1 millimeter space. So 24 total. Ooh, okay. So that's only... Okay. So let's go ahead and just... Let's go ahead and... How do we edit the sketch? Edit sketch. Okay. Let's go with 3 for now, and then we'll obviously need to change the clearance later. About the center, do 6. There may be a problem with the tolerances, because doing this will only leave us with 3 millimeters. We're going to do a 22 for now. Okay, I don't know why this is happening again. Okay, so if we add a 22, okay, let's see here, 22, 8's 4. Okay, so we need 4 here. Extrude 4 here. Okay, nice. Now I don't know how to bring this back, so what we're gonna do, since this happened last time, we're going to save. Go here, close out of this. Wait for it to upload. Click on it again. There we go. It's a glitch, I guess. I don't really know. Anyways, now that's working. We need to... Okay, let's see here. Cycloidal. Let's bring back all cycloidal. We just need 1 millimeter clearance, so we can do create sketch here. Is 3 millimeters is 3 millimeters good enough for it to sink into the... I really doubt 3 millimeters is enough. So we might need to opt out to use 35mm pens. So M3 by, you know what? Change of plans. We're gonna use 30. I don't wanna, but what we will do is, we have one. What we will do is make this 4 instead of 3, instead of 5 for each one. Okay, perfect. And these are still 30. Actually, let's do check M3 by 35. I mean, it definitely is available. 3 by 35mm rod. This is 6, so I feel like doing 6 would be the most optimal. Trying to think here. Okay. If we went 35, we would have extra 2.5mm on both sides. Okay, right now this is 7 point. Wait, what? Oh, 7, and this is 5. So we'll have 6 on both sides, and then we'll have 5 on both sides. That's going into the piece. Is 5mm good enough? Let's see here. 5mm, but that's 6mm. But the ball bearings are 6mm. You know what? I think 5 is good. 5 will do. So let's just go like this. This means we'll have 1mm of space for the thing. Okay, this is perfect actually. Wait, I don't know why I'm doing this side. Do 1 here, and we'll subtract 1 here. Okay, this should be 6, and this should be also be 6. Nice. Now let's create sketch. No, wrong one. Create a construction plane. Construct on this plane. We'll do 1mm. Earlier I was doing 0.5, but I think 1mm will be better for this, because apparently when I did it, it was very, very not good. It was very tight. Tolerances weren't good. Okay, we need to do a 50 about the center. So ball bearings will be, and we need to do the 6. Do a new body. So the ball bearing will be able to fit on here perfectly, and then we need to create a case around it. That's, let's see here, what is it? Where's the ball bearing? It's a 62. 62, yep. Nice, okay. So let's go look at the case. Okay, so since it's 1mm, what we need to do is extrude this down 1mm and extrude this side down 1mm too. Okay, now that we have this should, and it absolutely does not line up for some reason. Okay. Why is this two? I thought that's really, oh, I had, oh, okay, never mind. So let's do another millimeter here. Oh, yeah, oh my goodness, I'm so stupid, because I moved the thing. -3. Okay, now it should be good. Now we can do 62, and also we can add a fillet to these to make it very, very easily printable. And let's add a 62, so, Create sketch. 62, wherever that is. 62. Okay, we'll just stick with the 70. Let's do 6. And we can just create the sketch on this side too. 62 and 70. And this should be 6. I'm honestly liking this design because eventually what I can do is just CNC this instead of using metal rods, you know? So it would be the same thing essentially. Metal rods versus CNC metal, same thing, you know? Okay, this is awesome. This is awesome. This is very, very nice. Considering the 1mm space, we have total 1, 2, 3, 4mm clearance. I think that's enough. And now let's bring in. Okay, it's already here. Never mind. Let's do a 21 in the middle. -6. And now comes the important thing of. Okay, wait. Let me just. No, we don't need to do that. What we can do is just. For now, let's just go combine this, do cut each one of these. Keep tools. No, we don't need to keep tools because we can just flip this around. Bring in all the cycloids. Take this part right here. Do a move. Flip. No, what am I doing? Do a copy paste. Copy paste. Move. Okay, what is? Oh, this is in the way. I was wondering what it looked so weird. Move it down. Move it 180. Can make sure it lines up. Perfect. This looks like 1mm, right? It's 100% 1mm. 1mm, nice. Okay, now that we have this actually looks like very, very good design. Very compact. This got rid of a bunch of the bulk that I've been thinking. And the 3 teeth system, so it's less bulky, way more, it's double as strong basically. And cheaper and lighter, which is absolutely amazing. Okay. So, the things, what are they called? The dowel rods will be press fit into here with ball bearings. Center. This seems like a very, very simple design because the other design, bro, I spent so much time putting spacers in, like the little inserts or whatever. Well, not inserts, what is it called? The little. Yeah, no idea what they're called. Anyways. So for this design, let's bring in the cycloidal. So one very, 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 very major difference is here. Okay, this is 14. Okay. We can mount this directly on here. That's a new thing I've came up with. We don't need this right now. We can mount this. Okay, so this is the front. We can mount so basically the shaft, this shaft right here, we can extrude this. Actually, we can extrude this out 15 or 14. I actually added this custom shaft, basically, with a bolt and a nut that goes all the way through, and we can just set it right on here. Isn't that amazing? That's such a smart idea. So now you can have this entire piece just sitting like this. This gets rid of, look at this. Let's look at the overall. We'd still need to add a few. This is only 52. That's crazy. That is actually crazy. We also need to add like 52, so we need to add like 15 to 20, maybe less, probably less. So 70. That's the overall. My old design was 10mm more than that, so it's already pretty nice. Where's the old design? I think it's right here. Yeah, this is the old design. So basically we don't need this anymore. This big mess, we don't need this. And it will look so much better, and it will be way stronger than this, because this is a... So this is 6. This is... So 6 plus 6 is 12. This right here is a 4, 4, 8. This is 16. So 12 and 16. So we do have a performance increase here too. And I'm going to stop here. I'm going to go eat and I'll finish the rest later.